Day 699 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3418, maximum amount of money robot can earn. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given an n by n grid. A robot starts at the top left corner of the grid 0, 0 and wants to reach the bottom right corner n minus 1. The robot can move either right or down at any point in time. The grid contains a value, coins of ij, in each cell. If coins of ij is greater than or equal to 0, the robot gains that many coins. If coins of ij is less than 0, the robot encounters a robber and the robber steals the absolute value of coins ij coins. The robot has a special ability to neutralize robbers and at most 2 cells on its path, preventing them from stealing coins in those cells. Note, the robot's total coins can be negative. Return the maximum profit the robot can gain on the route. All right, y'all, so that may seem a little bit confusing at first, so let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So before we get into example 1, let me just go ahead and copy and paste this over here so y'all can get y'all handy dandy visual representation of what is going on. So this will be our n by n grid that we are working with. So let me just clean this up for y'all real quick. Boom, 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 boom. Oops. Boom, boom. Okay, that's our grid. Now let's get into example 1. So in example 1, our input coins equals a 2D array of integers or n by n grid. First array being 0, 1, 1. Next array being 1, negative 2, 3. And the last array is 2, negative 3, 4. Now remember, each one of these arrays is just a different row in our grid. Boom. And then this is our grid over here. This is what it looks like, the n by n grid. The output is 8. It says an optimal path for the maximum coins is. So we're going to start at 0, 0 with 0 coins. Coins equals 0. So 0, 0 is this right here. Boom. We're going to start right here. Boom. Then we're going to move to 0, 1. So 0, 1 would be this right here. Boom. So once we move to this right here, we're going to gain 1 coin. So let's just keep count of our coins right over here. Boom. Coins equals 1. Boom. So now we're right here at 0, 1. And then, so this right here, we get 1 coin. Boom. Then we're going to move to 1, 1 where there is a robber who steals 2 coins. The robot uses 1 neutralization here, avoiding a robbery. We still have 1 coin. So we're going to go from, we went from here, which is 0, 0, to here, which is 0, 1, to now we're going here, which is 1, 1. And as you can see, we're at 1, 1, this is less than 0, right? Because, boom, it's negative 2, which is less than 0. So that means a robber can steal up to 2 coins. However, it says right here, the robot has a special ability to neutralize robbers and at most 2 cells on its path, preventing them from stealing the coins. So we don't have the special ability to prevent just these 2, just 1 coin each, or excuse me, yeah, 1 coin each from here. We could neutralize this whole cell. So we still have an extra neutralization after we use this one, even though it's a 2 right here, negative 2 right here. We only are neutralizing this entire cell, which means we still have 1 neutralization left. But as for now, we're on this cell, we use our neutralization, so we're able to keep our coins equal to 1. Boom. Then from this cell, we're going to move to 1, 2. So 1, 2 would be, come down 1 over 1, 2. We're going to land on this 3. So now we're right here at this 3. Boom. So it says move to 1, 2, gaining 3 coins. So total coins is 1 plus 3 equals 4. So 1, 2 has this 3 right here. So we get 3 coins. We can add 3 to our pot. Boom. And now we have 4. Then from this 3, we're going to move to this 4, right? Boom. It says move to 2, 2, gaining 4 coins. Total coins 4 plus 4 plus 8. So since right here there's a 4, we add 4 to this 4, and now we have 8. Boom. In total, we have 8 coins. Boom. So just in case that didn't make sense, let's take a look at example 2. But that's how we got this output of 8 right here. Sorry, y'all. Boom. That's how we got this. Boom. So let's take a look at example 2. Example 2 is a little simpler. I'm not going to give you this whole visual representation because it's all the same element. But let's go. Or I guess I'll give you the visual representation. Why not? You know? Ain't no reason not to, I guess. Even though it's all the same. It still might help some people to be able to visualize this. So in example 2, our input coins equals a 2D array of integers. First array 10, 10, 10. Next array is 10, 10, 10. Boom. So this will be our first row. This will be our second row. Boom. Top row, bottom row. Boom. This time the output is 40. Explanation says an optimal path for the coin is we're going to start at 0, 0 with 10 coins. Let me put the coins down here too. Boom. So we're going to start right here. Boom. So as soon as we start right here, there's a 10. So now we have 10 coins. So let's just put a 1 right here. Boom. Then we're going to move to 0, 1, gaining 10 coins. So now we're going to move right here. This is our path, right? Boom. So our path leads us right here. We get another 10 coins. Boom. Put 2. Then we're going to move to 0, 2, gaining another 10 coins, right? So first we went here. 0, 0, then we went here, 0, 1. Now we're going here, 0, 2. Boom, another 10 coins. We can change this to a 3. Sorry, y'all, 3. Remember, the goal is to get to this bottom right corner. And we already went from here to here to here. So now we're going here to the bottom right corner. It says move to 1, 2, gaining the final 10 coins. 30 plus 10 equals 40. Boom, so we add this last final 10 coins. And now we have 40 coins and the output is 40. That's how we got this 40 or this 40 coins from this input up here. Boom, y'all. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Solution is not that difficult at all. We'll be using a little bit of dynamic programming. So I hope you're excited about that. Now let's get into it. Hold on, let me clean this up. Now let's get into it. Boom. So first thing we want to do, we want to get the number of rows and the number of columns. So we'll say let m equal coins dot count. That's going to get us the number of rows. Then we're going to say let n equal coins square bracket 0. Come outside of that dot count, and that will get us the number of columns. Boom. Now we need a state to represent our dynamic programming values, and each index of k is going to mean the maximum amount used at most k skips. So we're going to say let state colon open up the parentheses integer. So state is going to be an array of integers, and we're going to say set it equal to an array. Open up the parentheses is going to be repeating colon int dot min comma count colon 3. Boom. Now we need to create our dynamic programming array for the current row. So we'll come underneath this and we'll declare a variable called curRow colon. We'll say it's going to be a 2D array of integers. So square bracket, put int inside, and we are going to set that equal to an array. Open up this parentheses. It's going to be repeating colon another array, because remember it's a 2D array. So then we'll say open up those parentheses as well. And that's going to be repeating colon, or actually, sorry y'all. This is going to be is this, we don't need this second array right here because we're just going to be an array repeating state, which is already an array. Boom. So then we could say, sorry y'all, comma, count, colon, n plus 1. Make sure you close the parentheses. Boom. But yeah, even though this is a 2D array, since state is already array, we don't need to put repeating another array. We could just put repeating state. Boom. Now we need to iterate through each row. So we are going to say for I in 1 dot 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 m, open up the brackets. Then we're going to iterate through each column by saying for j in 1 dot 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 n, open up the brackets. Now we're going to create a variable which will hold the best value. If we take the current coin, then we can come from either the top cell or the left cell. So we'll declare a variable called prev1 and we'll set that equal to max, open up the parentheses, cur row, square bracket j, square bracket k, come outside of that, comma, cur row, square bracket j minus 1, come outside of that, square bracket k. Boom. Then we need to create prev2, which will be the best value if we skip the current coin, meaning we use one of our neutralizations. So we'll declare a variable called prev2 and we'll just set that equal to int.min to start. Then if no valid path exists yet, then we need to treat 0 as our starting point. So we'll say if prev1 equals int.min, open up the brackets, we'll say prev1 equals 0. Boom. Now we're only going to compute if we still have skips available. So we'll come underneath this and we'll say if k is less than 2, we're going to open up the brackets and we're going to use one skip and look at the states with k plus 1 skips already used. So we're going to say prev2 equals max, open up the parentheses, cur row, square bracket j, come outside of that, square bracket k plus 1, come outside of that, we're going to say comma, cur row, square bracket j minus 1, come outside of that, and we're going to say square bracket k plus 1. Boom. Now if no valid path, then we're going to treat it as 0. So we can come underneath this and we will say if prev2 equals int.min, open up the brackets, we're going to say prev2 equals 0. Boom. Then we need to come underneath this and we are going to say cur row, square bracket j, come outside of that, square bracket k, come outside of that, we're going to set that equal to max, open up the parentheses, prev1 plus coins, square bracket I, sorry y'all, square bracket I minus 1, come outside of that, and we're going to say square bracket j minus 1. Then we'll come outside of the square bracket, still inside the parentheses, and we'll say comma, prev2. Then we just need to return our result, which is the maximum amount at the bottom that we have by the time we reach the bottom right corner. With 0 skips remaining, we will come right here and we are going to say return cur row, square bracket n, square bracket 0. Boom, y'all. Let's give that a run. Let's see. Cannot find K. Oh, shoot. We need to try. So, hold on. Underneath this J, we got to say for K and 0 dot 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 2. open up the brackets, close this bracket, and we could just close it all the way down here, right here. Boom. Let me see. That should do the trick. Let's run it. Okay, can I find points? Sorry, y'all, there should be coins. Let's run it. It's accepted, so let's go ahead and submit it. Make sure it's stays accepted. And look at that, y'all. 67 milliseconds beats 100% of users. And just so you know, when we are checking this K checks the that's just so we can try all possible skip counts, right? So that's where this 2 comes from. We only have 2 skip counts. So this K represents our skip count. Sorry about that, y'all. Boom. But with that being said, before we go, make sure you get one more look at the code. This is the top part. This is the bottom part. And yeah, y'all, with that being said, I hope y'all learned something today. And I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.